Hello everyone, welcome to Math Tired Club. I hope you're doing well. Today I want to talk about factoring quadratics when a is not 1. I'm also gonna link the video that I had on factoring quadratics when a is 1 using mental foil in the description below. Also, don't forget to subscribe, like, and comment if the video was useful for you. So let's go ahead and talk about factoring. I want to talk about factoring quadratics using FOIL method, which is a very easy method to use in order to factor. So today I want to talk about factoring quadratics when a is not 1. And of course it's not 0, 2, because if it's 0, then we're not going to have any quadratic functions. And by quadratic functions, I mean the functions that their degree is 2. So as an example, I'm going to have this 6n squared plus 23n plus 7. So in order to factor any quadratic, the first thing you do is that you have to check if there is a GCF or not. If there was a GCF, and by GCF, I mean the greatest but common factor. And when I say common factor, I mean it has to be a number that is common in all of them, something that all of these numbers are divisible by. So if there were any GCFs, you would have factored it out. And if there are no GCFs, you're going to continue with factoring the function using FOIL. Okay, over here in this example that I have written for you, there are no GCFs. So what you're going to do is that you're going to go with FOIL. FOIL stands for first, outer, inner, and last. So it's first, outer, inner, and last. And the very first thing you need to do in order to be able to use FOIL is that you have to start with your first term. So I'm going to start with my first term. My first term here is 6. So the thing that I'm going to think about is, and also guys, don't forget the fact that we're not working with the variables. We're just looking for the numbers, and at the end, we're going to add the variables. So this is how FOIL is going to work, and it's pretty easy. Just stay with me. So I'm going to look for two numbers that if I multiply them, I'll get 6. The first thing that comes to my mind is 1 times 6 or 6 times 1. Guys, it is very important for you to remember that the order of the factors in the first term does not matter. So the order of the factors in the first term does not matter. So whether you write 1 times 6 or 6 times 1, just one of them is going to be enough for you, okay? So if you write 6 times 1, are you going to get the same answer at the end? Yes, you will. You will get the same answer. The only difference that you're going to have is the order of the parentheses. So for example, if it's like, I don't know, 2x plus 1 times x plus 2, it's going to be x plus 2 times 2x plus 1. That's the only difference it's going to make. And you know that is not like a different answer. It's just like a different order of multiplication. So the first thing that comes to my mind for making 6 by the multiplication of two factors is 1 times 6. The other thing is 2 times 3. But I have to first check 1 times 6 with the factors that I have for the last terms. And if they didn't work, I'm going to go with my other option. So over here, as you know, this b over here presents the sum. So in a quadratic function, this is going to present the product of the factors, and this presents the sum of the factors. So this is the sum and this is the product. So after this, after step number 1, I'm going to go for the last terms. Okay, so, and also something, pay attention to the sign of whatever you have in the sum part, okay? So for example, over here, the product is positive and the sum is also positive. So it means that both of the factors that they were multiplied by each other, they were both positive, so that their addition also became something positive as well. So I'm gonna have in the last term, how do I make 7 by the product of two numbers, the first thing that comes to my mind is 1 times 7 and 7 times 1. You might ask here that in the previous part, I did say that the order of the factors does not matter, but in here, I actually wrote both of the orders. Guys, in the last term, the order of the factors matter, and you're gonna get different answers with different orders. So let's see if that's actually true. So now I'm gonna try 1 times 6 with 1 times 7. So pay attention to this part. Over here, we have 4 terms. The outer terms are the terms that they are the furthest from each other. Such as in this example, 1 and 7 are the terms that they're the furthest to each other. Or they're the terms that they're standing in the outer parts. So it's going to be 1 times 7 for the outer. And the inner terms are the terms that they're the closest to each other, which is going to be 1 and 6. So it's going to be 1 times 6. This outer and inner are going to be added by each other, and it's supposed to actually present the sum. 7 plus 6 is going to be 13, and that's not going to work because the sum that I'm looking for is 23. Now I'm going to go on and I'm going to work with 1 times 7 and 7 times 1, and you're going to see that we're completely going to get a different answer. So pay attention again. The outer terms here are 1 times 1, and the inner terms are 6 times 7. 6 times 7 is 42, and 1 times 1 is 1. 1 plus 42 is going to be 43. Again, that's not 23, and that's not the sum that I was looking for. So now it's the time for me to move on to my next choice that I have, which is 2 times 3, which I'm going to write on the top. 2 times 3. The only option that I have for the last to make 7 is either 1 times 7 or 7 times 1. So first I'm going to try 2 times 3 and 1 times 7. So let's see what happens. So wait a second. Okay, we're not going to work with that. So the first thing that comes to your mind over here is the fact that the outer terms in here are 2 and 7. So it's going to be 2 times 7 plus 3 times 1. 2 times 7 is 14, and 3 times 1 is 3. 14 plus 3 is 17, and that's not the sum that I'm looking for. Now I'm going to go on and work with 2 times 3 and 7 times 1. 2 times 1 plus 3 times 7, outer and the inner, is going to be 2 plus 21, which is 23. And that's the sum that I was looking for. After finding the first and the last term, this is what you're going to do. You're going to have 2 parentheses. You're going to put the variable inside them, which was n, by the way. So it is, listen, these are the first of each parentheses, and these are the last of each parentheses. This part is the part that some students find critical. So pay attention. Over here, you're going to have 2 terms, right? Getting added or subtracted by each other. These are the first of each parentheses, and these are the last of each parentheses. So the first that I have found are gonna go into the 2 different parentheses as their first term, and their order matters. So the first one goes into the first parentheses, and it's gonna be 2, and the second one goes into the second parentheses, and it's gonna be 3. And then these are the last terms of each parentheses. Again, the order matters. So the first one goes into the first parentheses, it's positive 7. And the second one goes into the second parentheses, and it's 1. In order to check if your answers are correct or not, you're going to multiply these back to each other to check if you have got the right answer. So it's going to be 6n squared plus 2n plus 21n plus 7. Guys, I want you to pay attention to something. what you have over here is exactly what you have over here, 2 plus 21. So this is going to be 2 plus 21. Do you see that? 23, and because they're like terms, you add them, plus 7, and that's going to be the answer. I'm going to do one more question that I'm sure you're going to find very, very useful, and it's going to be this one. So, for example, look at this question, everyone. 2y squared minus 5y plus 2. The question gives us this, and it asks us to factor it. So again, I'm going to check if there are any GCFs or not. There are no GCFs here, and then I'm going to go with FOIL. First, outer, inner, last. My first term, I always start with the first term, is 2, so it's going to be 1 times 2. That's how I'm going to make 2. Either 1 times 2 or 2 times 1, just one of them, because in the first term, the order of the factors does not matter. And then my last term, which is the product, as you know, this is the product, and this is the sum, is positive 2. So the first thing that comes to my mind for positive 2 is either 1 times 2 or 2 times 1. But the thing is, I have to pay attention to the fact that the factors that I'm using and I'm writing here, when I'm multiplying them, which is the product, the sign of it, it's positive. But when I'm adding them, it's supposed to be giving me a negative number. So how's that possible that when I multiply two numbers, I'm going to end up with a positive answer, but when I add the same exact two numbers, I'm going to end up with a negative answer? Both of the factors are supposed to be negative so that when I multiply them, I'll get something positive, because negative times negative is positive. And when I add them, I'll get something negative. So that's how it's possible. So instead of writing 1 times 2, I'm going to write negative 1 times negative 2 in the last term, because the answer to this is going to be positive 2, but then again, the sum part is going to give me a negative answer, as I really need here. So outer terms are the terms that they're standing in the outer parts, which is going to be 1 times negative 2, and the inner terms 2 times negative 1. This one's not going to give me the answer because the answer is going to be negative 4. I'm going to try 1 times 2 and negative 2 times negative 1. So the outer terms are 1 and negative 1, and the inner terms are 2 and negative 2. Negative 1 minus 4 is negative 5. That's the correct answer. I have found my factors, so I'm going to box it. And then to write the answer, I'm going to draw 2 parentheses. I'm going to write it over here, guys. I'm going to have 2 parentheses. I'm going to put the variable inside. Guys, these are the first of each parentheses, and these are the lasts of each parentheses. So it is going to be 1, as I have over here, and 2 as the first term of the second parentheses, negative 2, and negative 1. And if I want to check my answer, I only need to multiply these by each other, and then I can actually very, very easily check my answer. So my last example would be this. So you might ask that this process is very long and it's going to take a lot of your time. No, guys, it's not actually going to take a lot of your time, because I was trying to work as if it's, for example, your first time. So you would go through all those guesses, but after a while, after doing some questions, you're going to be making better guesses for sure. So your first or your second guess is going to be the answer. So this is given to me and it tells me to factor this. So there are no GCFs, so I'm going to go with FOIL. So I'm going to have, my first term is 2. I'm going to have 2 times 1. My last term is negative 3. So I'm supposed to have something like negative 3 times positive 1, for example. Let's try that. So outer terms are going to be 2 and 1, and the inner terms are going to be 1 and negative 3. So it's going to be 2 minus 3, which is negative 1. And that's the sum that I was looking for. I have found my factors. I'm going to have 2 parentheses. I'm going to put the variable inside. These are the firsts of each, and these are the lasts of each. So this is going to be 2, this is going to be 1, -3, and +1. So guys, I hope you understood this lesson. I'm sure you're gonna do pretty great. I'm gonna write 2 examples so that you can practice after this session and see if you have actually understood it or not. The first one is gonna be 8y squared minus 10y minus 3, and the second one's going to be 25x to the power of 2 minus 10x minus 15. And let's add the last one, which is 54p squared plus 87p plus 28. Don't be scared of the numbers. You might find the GCF in some of them, and the other ones are going to be super duper easy for you to do. I hope that you have learned the lesson. Wish you guys a great day. Don't forget to follow, subscribe, and leave comments. Have a great day. Bye.